Welcome! Today, we'll create a virtual network in the Azure environment with 2 virtual machines hosting web servers. Then, we'll set up a basic load balancer to distribute incoming traffic across the backend virtual machines. Here's the plan. First, we'll create a virtual network with a subnet. Second, we'll set up 2 identical virtual machines and install web server, IIS, on each VM. Third, we'll configure a load balancer with a frontend IP, backend pools, and a health probe. Finally, we'll test if the load balancer is functioning properly. Let's get started. Step 1. We are going to be creating a virtual network VNet. Navigate to Virtual Networks. Select your subscription and resource group. Enter a virtual network name. It should be identified easily in the future. Select the same region as the resource group. In the IP Addresses tab, configure the address space by entering this address range. Enter 10.1.0.0/16. I'll delete the default name of the subnet and create a new one. For subnet name, enter backend pool. This will be associated with the virtual machines that are going to be created in the next section. For subnet address range, enter 10.1.0.0/24. When everything looks ready to be deployed, click Review plus Create, and then Create. Step 2. We are going to create 2 virtual machines that are Windows Server 2019 naming VM1 and VM2. Navigate to Virtual Machines. Fill in the details for the first VM. Select your subscription and resource group. Enter VM1 for virtual machine name. Availability sets are logical groupings of VMs that reduce the chance of correlated failures, bringing down related VMs at the same time. Availability sets place VMs in different fault domains for better reliability. When using availability sets, create 2 or more VMs within an availability set. The update domain groups VMs that can be rebooted at the same time. This allows you to apply updates while knowing that only one update domain grouping will be offline at a time. The fault domain groups your VMs by common power source and network switch. To protect against a physical power or networking failure by having VMs in different fault domains. For the size, select a size like standard B2S. Next, enter a username and password. To access the VMs from the public internet, we're going to allow certain inbound ports, such as HTTP port 80 and RDP port 3389. For disk, we'll just select standard SSD. In the Networking tab. For Virtual Network, select the name of the virtual network created in the first step, which is MyVNet. For subnet, choose the one we created earlier, called backend pool. For public IP, create a new one with basic SKU and static IP assignment. We're going to skip the load balancing option for now and revisit it later. When everything is set, deploy the virtual machine by clicking Review plus Create, and then Create. In the next part, we'll repeat these steps to create the second VM with similar configurations. Step 3. Install a Windows Web Server (IIS) on each VM. First, connect to the first VM via RDP Remote Desktop Connection, which we allow as inbound port 3389. Download and open the RDP file and hit Connect. For the first VM, we'll use PowerShell for a quick install of IIS. Open PowerShell. Run the following command. Install Windows feature name web server include management tools. Once that's done, create a simple HTML page on each VM to identify them. Open Notepad and create a .txt file named default. Change its extension to .html and add your content. I'll just say welcome to VM1 for now. Save the file in the following location under C, under inetpub under www root. Repeat these steps for VM2, changing the content of the default .html file to welcome to VM2. This way, we can easily differentiate them when we test the load balancer at the end. Skip the next few minutes if you want to. Next, we're going to create a load balancer to distribute traffic among our backend virtual machines. Select the subscription and resource group as usual. For the name of load balancer, enter the easy-to-identify name. I'll just enter MyLB. Select the same region. And basic SKU. For type, we'll select public load balancer. Use a public load balancer for external traffic coming from the internet, and an internal load balancer for internal traffic within your virtual network. Public load balancer distributes incoming internet traffic to your virtual machines, VMs, or services. Frontend IP has a public IP address that is accessible from the internet. It's ideal for applications that need to be accessed from outside your virtual network, such as web servers or public-facing APIs. For the frontend IP configuration, enter my frontend 4 name. Add a public IP address with static IP address assignment. Now, save the configurations and continue to add a backend pool. Click Add. Add a name of your choice and select the virtual network MyVNet that we created. We'll have to add IP configurations to the backend pool by selecting the two virtual machines VM1 and VM2. Now you can see two VMs with different IP addresses and network interfaces in the backend pool. Next, let's configure the load balancing rules. Click Add, and assign a name of your choice for the rule. Select My Frontend for frontend IP address, and an existing backend pool from the drop-down list. Protocol, select TCP. Port, enter 80 for HTTP. Backend port, enter 80. We'll create a new health probe in the load balancing rule. A health probe is a crucial component that helps ensure your load balancer is distributing traffic only to healthy and responsive virtual machines by regularly checking the status of your VMs by sending requests to a specified endpoint, such as an HTTP URL or a TCP port. Type a health probe name of your choice and select TCP as protocol, and the same port as HTTP 80. You can set it to check port 80 every 5 seconds. If the port is open and responsive, the VM is healthy. Click Review plus Create, and then Create. And that's it. We've set up a load balancer. Final part is where we're gonna test if the load balancer is functioning properly. Go to Load Balancer in the Resource group and under Settings, click on Frontend IP Configuration. See the public IP address 40.71.27.78, which we will use to access it via an internet browser. Open a web browser and enter the address in this format: http://IP address/default.html. Try refreshing the browser for it to display content from another VM. You can see alternating responses. Welcome to VM2! As a first response. A load balancer ensured the reliability, availability, and performance of applications and services by distributing incoming traffic across multiple virtual machines or services. It enables automatic scaling based on demand, allowing your applications to handle varying levels of traffic. It reduces the risk of any single server being overwhelmed, which can lead to better performance and quicker response times for users. And next, welcome to VM1.